We have finished for the lessons of indices, surds, and exponential equations from the past previous lessons, right? So today, the new lesson we gonna learn is logarithms. First of all, we have to see about the relationship between exponent and logarithms. Exponent is the inversal functions of logarithms, and logarithm is the inverse functions of exponent. So both of exponent and logarithms are the inversal function to each other. Okay, so the bit first we know that 10 equal to 10 power 1. This is the exponential form, right, or the index form. So also if I say 100, I can write it down equal to 10 power 2, right? Now we know the index here should be 1 and this should be power 2. But if I say 60 equal to 10 power x is unknown. How we can get the value of x in this case? X here. So it's hard, right? Because from here you can see the base and what index gonna be. But then this one is different though. Because 60 it's really hard to get the value of x within the base with the base 10 here. So this pattern, like this equation, is the most simplest term. So we couldn't go for the next step, right, to get the value of x here. Once you reach to this level, we have to think about the logarithms to help us to find the value of x. Then, for example, then the relationship now, the relationship between the two forms is only the base. We have to convert the base or move the base between two of them. For example, this is the exponent, this is the index form, right? I want to convert this one to logarithm. So I get this one. So if I say I have my y right now, the y now equal to 60, right? And a is 10, and this x is a power. So now from this is the exponential pattern. So I want to convert to logarithms. So in this case, this is the base of exponent. I have to move this a, the base a, to be base of logarithm. So then from this, I will take log y. Okay, and then base a here, base a here. I move down to be the base of the log. So I write a here. Okay, then equal to x, the index, move down to take space of a. So x gonna be this position. X gonna be there. Okay, then this the idea from exponent, convert exponent to logarithmic form. Okay, so then how we convert from this one, say this example. Then you can have, you convert, this is exponent form, right? Exponential form. So you take log, this 10 is a base of exponent. This 10 is a base of exponent. So you take log 60. Move the base 10 of exponent to be a base of logarithms. So 10 here, 10 here, right? Write it down to be base of the logarithm. And then your x, move it down to take place of 10. So become, this side become x. Okay, so now we get the value of x now by using logarithm. Then you 1.778, 1.778. So log 60 base 10 equal to or approximate 1.778. Okay, convert the following to logarithmic form. Okay, A, say if I have 4 power 2 equal to 16. Now, right now is the exponent is a exponential form, right? So we want to convert into a term of logarithm. So then, see, you have to find out which one is the base of exponent. The base of exponent is what? 4, right? This 4 is a base of exponent. Then you take log 16. Take log 16 and change this base 4 here. Not change, I mean move this base 4 down here to be a base of logarithms. And then 2 you move to take place of number 4. Takes a place of number 4. So 2 going to be down here. Okay, so we have log 16 base 4 equal to 2. Okay, maybe more example. Say if I have 2 power 5 equal to 32, right? Now we convert this exponent, this index form to logarithmic form. So then we have, this is a base, 2 is a base. So we take log 32. Move the base 2 of exponent to be a base of logarithm. So 2 like down here. 5, move it down to take place of number 2. 5 take place of number 2. So equal to 5 here. Okay, so more example, one more example. If I have 2 power negative 1 equal to 1 over 2. Again, check which one is the base. The base of the exponent, this one, right? 2 here. So then you take log 1 or 2. Then you take log 1 over 2. And the base of exponent here equal to 2 here. Write it down here. And negative 1, move it down to take place of number 2. So become negative 1. Okay, so this example convert from exponent to logs. Now next one we see some more example. Convert from index form. Convert from logarithm to index form. Okay, see the next example. So more example. Convert the following. To index form. Okay, example. Say if I have 2 equal to log 25 base 5. First of all, we have to see which one is the base of logarithms, right? So now 5, right? Let me see, it's like different number, like the different color, I mean. So then 5 is a base. Then you move 5 to this side, right? And put 2 up to be index. So 5 move, take place of number 2. And to move it up to be index of 5, to be an index of 5. When you move this log word gone, so this side you write down equal to 25. Okay. Now we see more example. If I have 1/2 equal to log square root 2 base 2. The first step is take a look at the base. Which is the base of this question? The base of logarithms? 2, right? The number 2 here. 2 is the base. So then again, move this to the base of 2 to this side. So you write 2 down here. Push 1/2 up to be an index of 2. Then equal, when you move log word gone, you left only square root 2. So you write down here. Okay, this convert the logarithm to index or to exponent. So if a equal to 1, then 1 power 2 equal to 1. So from this one, this exponential form, right? I want to convert this to logarithm in the term of logarithms. So this one, we take a look again. The first we have to consider is the base, right? Which one is the base? Now 1 is a base, power 2. So then I take log number 1 here. So I take log 1, this one, okay? Then I move the base of exponent. Does it mean 1 here? Write it down here. So I just different color. This one, okay? To be the base of this one. Okay. And then equal to the 2, index 2 move down, take place of number 1 here. So equal to 2 here. So this 2 going to be the 2 here. Okay, now we try one more. Say if at the same time, if 1 power 3 still equal to 1, right? Now I want to convert this one to logarithm or to the logarithmic pattern. How to do the same way? I take log of this one, right? So this one become log 1 here. And then this is the base, right? I move to be base of logarithm here. Be here. I move down to take place of number 1 here. So equal to 3. Okay, now you observe these two cases. Log 1 base 1 equal to 2, log 1 base 1 equal to 3 is incorrect, right? That it shouldn't be that way. So in this case, they have some exception. Can be the definition or can count to be a formula of logarithm, one of formula log 1 base 1 does not have a definite value. And also can say log y base a is not defined. It's not defined when base a equal to 1. Okay, that means for log y base a, log y base a to be defined two conditions. First one, y must be greater than 0. The second condition, a must be greater than 0 also, and also a is not equal to 1. Okay, so this is very important, and everyone should keep in mind with this definition of the logarithm. Okay. Now from this example, from this definition, I can give you some example related to this one. Okay. So say if I have this one, if I have log 3 base 1, and also say log 5 base 4, base -4 maybe, -4, or log -1 base 6. Okay, so you can see this on example a lot detail here. So example, this log 3 base 1, right? And then a, say a is not equal to 1. So we have this and base become 1. So this is undefined. Also, this one, -1 is a position of y should be greater than 0. But we have -1 which is less than 0. So this one is undivided also. And this is the same thing here, become -4. A should be what? Greater than 0 and is not equal to 1. So then this one, no solution either. Okay. So this example explain for the definition of logarithms. Now we see more example. Now we gonna do proof some formula first, and then we can use the formula to solve our questions. So this one example, just say for prove the formula. Okay, so we prove when we prove this one, if we have log a base a equal to 1, how we gonna prove this is one formula? Okay, but we're gonna prove this formula is correct. Then I can write it this way: a equal to a power 1, right? Now the next step, you observe which one's the base. This is the exponent. This is the exponential pattern. So you have to find the base. So this a is a base. So I take log a. So I take log a of this one. Okay. Take log this one a equal to, and then this is the base of exponent. I move this one, this a. I move this a down to be the base of the log, to be a base of the log. And then number one, take place of this a. So one going to be lie down here. This form the definition of logarithms, the period we just finished, the period example. So now we prove now log a base a equal to 1, same as this one. So this one we prove. We prove the formula. Okay, so we prove the formula. Now we see another formula we prove. This is the example one A, next one B. If I have log 1 base A equal to 0, now we want to prove this one, log 1 base A equal to 0. A power 0 equal to 1, right? Okay, we know A power 0 equal to 1. So I want convert the base of this logarithm, which is equal to A, to be base of index, to be base of exponent. Okay, so I take log 1, and this is a base of exponent. I move it, this A, I move it down. This A here, I move it down to be base of logarithms. And then 0 move down to take place of A. So become 0 here. So now this equal to the one we need to prove. Okay, this is the one we prove. The formulas. So these two is the formulas. Okay. So now see the last proof for one more formula. X power R base A equal to R log X base A. This is our R belong to real numbers. Okay. So now we want to prove this equal to this. How to do the solution here. So we get this one, let log X base A, log X base A here equal to M. Okay, so we have equal to log X base A first. From this, we use the definition of logarithms again. Move the base, this is A is a base, move to this side, right? So we move A here is a base of logarithms to this side. So become A. Then M, move it up to be index of A. Okay, M moved up. And then this one, once you convert this step, your log lighting the words gone. So this side you left X. Okay. Now you take a look because the formula, the question we have log X power R base A, X power R. Now I have X here now. So I need power R, right? From this step, I will power both sides with R. Power both sides. So we have A power M, power both sides with R. So I have X power R here. Okay, now I have X power R already. Then I need to convert to log. This is the exponent. So I will take A as the base of exponent. So then after this, I have to take log, right? Log X power R. And this is A power, Can I write this one the next step for here first? Become a, I can simplify first, a power mr equal to x power r. Okay, so now I convert this a is a base, correct, of the exponent. So I move this a, I move this a, I move this a here down to the base of the log. Okay. This one I haven't finished on this side, so this is still x power r. Haven't get. So I from here I simplify, I get this one, right? And then next step I want to convert to logarithms. So a is a base of exponent. So I move a down here. I take log x power r and move base a down to be base of the logarithms. And then mr is a power, right? So move down, take place of a. So this side I left mr. Everyone get it? So after this, we know m equal to log x base a. So you replace the value of m with this one. Okay, so m equal to log x base a. So you write log x base a times r, right? And then equal to log x power r base a. So log x base a times r, I can write r log x base a, right? I move r to the front. Correct. So I move r here times log x base a equal to log x power r base a. So we got the answer now. You see log this one, why I can move r to the front, like when you have 2 times 3, I can write 3 times 2, correct? So the same idea. So I can write r in the front because I want to write the same pattern with the equation. So from this one, r log x base a equal to this one, right? This one. Same as this one, correct? Same as the questions. And then base a, same as this side, right? So our proof is finished. So then equation, this proof is finished. Okay, because both sides equal, same with the equations. So again, from this example A, B, and this one C, 3 of these are the formula of logarithms. So you have to keep in mind, that means log A base A equal to 1, log 1 base A equal to 0, and log x power r base A equal to log r log x base A. Okay, these are formula of logarithms. Okay, now we go one a few more example. Okay, by using the formula we just finished. Example. They solve the equation I have log x base 3 equal to 2. How we solve this equation? Use the same way. First step, consider every time both exponent and logarithms. Consider the base. Base is what? What is the base? 3. Okay. 3 is the base. Then put to the other side, push it up. So then 3 gonna be this side. 2 push it up, become index. Okay. Then when you convert this, your log word gone. You left x on the left hand side. So you have x equal to 9. That's the answer, x equal to 9. Now see, next example, B. Okay, B. X equal to log 16 base 1 over 2. Same thing, first step, observe where is the base. The base is 1 over 2, right? Sorry. Then you move 1 over 2 to the other side. So you have 1 over 2, and the x move it up to be the index of 1 over 2. So, but this one you have to write the whole thing with the bracket and power x. When you convert this, the word log gone, no more writing. Then 16 write down the same place. So now how you solve for the value of x, this step, everyone know. We use the exponential equation, right? You see the base 2, so you convert 16 to be base 2. So 16 is 2 power 4, right? And move this one up, make it the same base. So 2 move it up become -1. And then the whole thing power x. Okay. So then you have the same base. So we have negative x equal to 4. That means our x equal to -4. Final answer. And every time you have to check the value of x also, say make sure they are the same. They work for they are correct answer for the original question. You have to check it. Okay. Just how to check? You just replace x equal to 9 there. Okay, and then we can use the formula. We just finished period 1, have 3 formula, right? Maybe I check this one, right? We work together for this one. Log x base 3, x equal to 9. So you write 9 here, base 3 here, equal to 2. Now 9 we can convert to, change to be base 3, the same here, same with the base. So we have log 3 power 2 base 3, right? Equal to 2. Then you can, this is a formula, we just finished the proving the formula. We have log x power r base a, right? Equal to r log x base a. Now you convert this one to use apply from the formula here. So from formula is the 2, right? So I can move 2 here to the front here. So I have 2 log 3 base 3 equal to 2. And again, we have the formula. We just finished the proving. We have what? Log a base a equal to 1, right? So now we can apply here log a base a. That means log 3 base 3, the same. So this one we have log 3 base 3 equal to 1 from this formula. So we have 2 times 1 equal to 2. So then correct. So our x equal to 9. This one correct. Okay. At the same time, you can check for question B. Also replace x with the -4. Okay. And then you do the same way. Okay. When then we go another example, you check the same way. Okay. Go the next one. The last example. If I have equation of this one, 4x minus 3 with x equal to 2. Okay, looking first step, base, x is a base. Then put up to the other side. So x gonna be here. Put 2 up to be a power of x. Then when you convert this log word gone, you left 4x minus 3. So you write down this side 4x minus 3. So from this one, we're gonna have x squared minus 4x plus 3, right, equal to 0. Then you can factor it x, 3 here, 1 here. And because we need middle term with a negative sign, 4x, so this one should be negative for 4. Because we can check negative 3 times negative 1 come up become plus 3. And the middle term negative 3x and negative 1x, sum it up become negative 4x, so it's work. And the first term x times x become x squared. Yes, so it's okay. Then we have x equal to 3 or equal to 1. X in there in the equations. So you have log x3, where 3 times 4 becomes 12 minus 3, and x base is 3, replace it. So now we have 12, take it, 3 become 9, right? Base 3, so equal to 2. Now from this, you can convert 9 to be base 3, right? So you have log 3 power 2 base 3 equal to 2. Now this, the index, this is a formula, correct? Formula, we just finished. One more time. Log x power r base a equal to r log x base a. This one 2. So you move 2 to the front. So what we have next? Gonna be 2 log 3 base 3 equal to 2. But the formula again, we know this one is log a base a, right, equal to 1. So we know this one equal to 1. Then you have 2 times 1 equal to 2. So this one correct. That means x equal to 3 is a part of solution of the questions. So this one okay. Now next you check, replace back to the questions. So we have x equal to 1, 4 times 1 is 4. So you have 4 minus 3 base 1, x equal to 1 equal to 2. So you have 4 minus 3 become 1 base 1 equal to 2. Now don't forget the last example we consider when we observe log 1 base 1 is undivided, right? Because your formula, this is very important, okay? Log y base a, the formula, the definition, or can say definition of logarithms, our y must be greater than 0 and a must be greater than 0 also, and a is not equal to 1. So in this case, take a look. Y is 1. It's okay, right? Because greater than 0. But the base 1 is equal to 1, but the condition says is not equal to 1. So this one doesn't work. So then equal to 1, or say x equal to 1 here, is rejected. Okay, so only x equal to 3 is the solution of this equation. Okay, so I think that's all for today. If you have any question, again, you just ask me for the live group or individual question to practice also. That's all for today. Bye bye.